All right, guys, get a sound check. Good to go. Hey, welcome to our 2019 Summer Outlook. For those of you who are joining us, really appreciate you taking time out of your day to check out our Outlook and all the research we put into everything. We do these, I don't know, 4 times a year and put a lot of research into the seasonal outlook. As difficult as they might be, we get a lot of at least a good idea on what the summer season ahead might have in store. So with me, I have Brett Waltz, meteorologist Brett Waltz. I have Nathan Kitchens and Kirk Hins, and we will all kind of be talking about this as we go in terms of what we're seeing in the research, what we think the forecast is going to do. We'll bounce ideas off of each other, and then we will take questions. So you can ask questions in here, and I would encourage you to do so, but please wait until after, towards the end, and I will address your questions. So if you have them, please ask them. Okay, so let's get started. What we're going to talk about is kind of what we're going to review. We're obviously going to be reviewing the major pattern drivers for the summer forecast, discussing our analog package. And for those of you that are new, an analog is basically a year where the weather pattern may have been similar. The drivers may have been similar. The ocean temperature profile may have been similar. Doesn't mean it's going to be an outcome. Okay, that's a common misconception. Is BAM Weather said the analog was 2012 and it's going to be 2012 again. That's not what that means. It just means that it's an analog to discuss the possible pattern. Okay, we'll look at our seasonal models. We will unveil the outlook and we'll talk about our energy report. We'll also talk about how summer weather could impact your business, whether it be outdoor events, farming, whatever the case may be. What kind of weather are we anticipating and how might that impact you going forward? Okay, so let's get into it. All right, the first things first, we have had a considerable amount of data shift towards a very active pattern in the next couple of weeks. Basically what's happening is we're going into a pattern that may resemble shades of April 2017, where we had a big eastern U.S. ridge and we had just copious amounts of rainfall. The problem with a lot of issues in 2017 were everyone kept trying to plant, and the forecast kept getting wetter, and so replants after replant after replant continued to occur. We strongly encourage you to listen to the weather forecast, especially 5, 6, 7 days out, and get a good idea on what may be coming so you don't have to do that. There's no reason to do that when we can help you not have to do that. Bottom line is that a very active pattern is in the cards, and we're basically kind of favoring, let me get a color here, we're kind of favoring this area here to be pretty doggone active to end April and open May. So something that to be watching, excessive rainfall, flooding, all that stuff is certainly a possibility and something we want to kind of keep you abreast to going forward. So a very active pattern upcoming. Field conditions or getting field work in is going to be pretty difficult, especially for those of you in the southern and eastern ag belt. Okay, so let's get into this. We'll talk about El Nino evolution, and let's go to Brett. Brett, kind of give us your ideas on how we formulated our analogs based on evolution, and what exactly does ENSO evolution, actually mean?
Sure, Michael, thanks. The way we went about this is we looked at the last 6 months or so, basically the last couple of seasons of ENSO and how it's progressed, how over spring we've been in a very steady state. We really haven't changed our ENSO value. You can see our 6-month values at 0.8. We've been pretty steady around there for the good part of spring. And so what we did to formulate these analogs we're going to show you here in a couple of slides is we looked at years that were pretty steady through spring, that had an El Nino in winter and was rising. And we look for years that continue to stay steady in summer. And you can see that down on the bottom left. That is the multi-model ensemble, the IRI, and it shows a generally steady state, weak to moderate El Nino throughout summertime. And it's actually a pretty rare case here. There's not a whole lot of years that have done what this year is doing. So it did make this difficult, but it goes to show that each year is different. We can get all these kinds of different patterns, but when we get this type of evolution, what we want to go back is look at years that are the most similar. And that's really just what we're doing here. Enso evolution is just years that are tracking most similarly as far as the actual Enso value to this year here. And you can see one of the things that we're taking into account too is how does this evolution impact our weather into summer. So on the bottom, as Michael has his arrow there, we've got orange being the current evolution, and then the blue below being what would be a drier risk for summer. Oftentimes when we have an El Nino in winter, we go into a more neutral or even a La Nina state in summer. Clearly, that's not happening this year. That does negate some of the dry risk that some of those analogs there would suggest that Michael has his arrow. And then as we continue on and look at our analogs on the next slide, and you can see, as Michael has pointed out before we switch slides there, subsurface warmth, that's important to touch on. It gives us a good indicator that El Nino is going to sustain. There's a ton of warmth to deal with in the lower sections of the ocean there, or I should say the upper sections, which gives us a good idea that we can continue to expect these El Nino conditions throughout a good part of summer.
Yeah, and I would say to touch on that too, Brett, is that when you look at this subsurface warmth, this graphic that we have here on the bottom right, note that from about 150 east to about 90 west, it's all warmth. And so what we see happening now is that perhaps we're setting the stage for a basin-wide typical El
Mm-hmm.
Nino that may not only be moderate, but borderline strong
Yeah.
over the next 4 to 6 weeks as we have some things working in that favor. So certainly something interesting. Hey, real quick, a programming note here. If you are on mobile and you want to see our face versus the screen, you can swipe left or right to see a different screen, just so you know. So, so let's talk about the El Nino evolution analogs. And I want to make sure that we touch on this in very clearly on analogs, because just because a certain area says dry or wet does not mean this is going to be the outcome because that's what the analog package says. What we're looking for here are general patterns. Generally, what you can take away from the evolution here of these analogs is that I can draw this big green oval generally across the large chunk of the US, and most of it is above normal in precipitation. Month by month, it becomes a little less useful. Overall, perhaps you're a little bit drier in the northern sections or northeastern sections of the plains. Regardless, the general pattern that the analog suggests is a wetter growing season. Okay, if you live here in Austin, Texas, and you say, oh, I'm going to be drier than normal because Michael's map has a little yellow dot on it, and I'm going to be dry. That's not how these work. These maps, they don't have this capability nor the skill for that to happen, for that to even be a possibility. So make sure you understand when you're looking at seasonal models, seasonal predictions, the bottom line is that we are looking for a general pattern or a theme. Okay. Kirk, why don't you talk a little bit? We're talking about the evolution of El Nino, and we're talking about how we could go into this more of a moderate, borderline, maybe strong El Nino. What drivers right now are impacting this continued El Nino event?
Yeah, so first of all, El Nino is the equatorial Pacific, basically smack dab right in the center of the Pacific Ocean. And like Brett said as well, we're looking at that subsurface warmth. So when you see all of that, and it's not just the orange and the red there as well. Oftentimes an indicator where you could be weakening an Enso event or El Nino event is when you see that blue start working up towards the surface. And we just don't see that as well. And we also see other indicators like across the globe in terms of, and I'll make this as simple as possible, it's called what we call like a westerly wind burst, or just another burst of westerly winds. And I know we don't have that shown here, but the forecast ahead over the next 2 to 4 weeks is to see another strong burst of those westerly winds. And El Nino essentially is a westerly wind across the equatorial Pacific. So not only do we currently have a basin-wide, decently strong El Nino, we see additional support for that to continue here. So, and the thing also I want to clarify with El Ninos or just Enso in general here is these trends, even though you may be declining or increasing it, they take a lot longer in reality than a seasonal model we'll look at, or just in reality how that pans out. So I think even if we continue El Nino, but maybe say hypothetically we drop it as we go into summer or into summer, it's still going to feel like El Nino for going into summer. So why does that matter? Well, if we're increasing El Nino going into May, pretty darn confident that you're going to feel El Nino for overall in the summer. And what those risks, like Michael showed here, is you look at June and you look at July and you look at August and you see a heck of a lot more green on these maps than you do of the yellow and orange. And also, just for Indianapolis, for example, we're over 5 inches above normal for precipitation. And when you get a lot of wet conditions, oftentimes you can continue to be wet as well. So you look at temperatures as well, you get a lot of precipitation to work in. It makes it even harder to get warm. So that's a pretty common theme. You got June, you got July, you got August. You see a heck of a lot more blue on this map versus say even last year as well. So again, these are analog years. This isn't necessarily saying this is 100% our forecast. We look for tendency years as well. But if I had to recap El Nino continuing, we're looking for precipitation risks to stay up. And, no real, if you look at the drought monitor, which we'll show you here in a second, there's just no real risk for running dry widespread. And, again, the more moisture you have, the harder it is, to warm up as well. So I just think that theme is just going to continue. El Nino is just going to continue to probably continue as well. So
to touch on that, you talked about it being very wet. And I think that what that can mean is when we're looking at a temperature side of things, maybe a lack thereof of heat waves and significant heat. But on the flip side of that, overnight low temperatures may have a hard time cooling off and being below normal. So what may negate these cooler risks is overnight lows with all these saturated soils. So that is something to consider, that low temperatures at night might be up a little bit. Not saying it's going to necessarily impact much. Let's be honest, it takes a heck of a lot to make a dent in things, but that is something to consider going forward.
There's something also I wanted to mention. Yesterday, we also looked at years that were, I still muted? I think I'm unmuted now.
Okay, go ahead.
Also want to mention yesterday, we also tried to break down some years that had El Nino in the spring that carried into summer that followed this wet trend. We've had a very wet year up to this point all over the central US, and wanted to look at those years and see how they trended in the summer. And they also followed these trends here of pretty wet conditions for most areas, and temperatures were pretty cold in those years as well. So if you want to just look at years and say what years were wet in those El Nino years and carry over into summer, they also followed a cooler and wetter trend as well. So
what year sticks out to you in your research?
58 was actually the closest, I would say.
Okay.
91 wasn't bad either.
Okay. All right, so going forward, these are great points. And what we're going to do now is there are other factors that we consider. So El Nino is in the Pacific Ocean. We also look at factors in the Atlantic Ocean, which is what we call the AMO, or the Atlantic Multidecadal Oscillation. Has a very high correlation to weather in the US. Brett, talk about what this means, where we are with the AMO, and how it may relate to the Pacific, and ultimately tell me how this impacts weather in the United States.
Absolutely, yeah. The AMO, I think, has been probably a very untalked about pattern driver over the past 3 years. We've seen one El Nino event this last year, and then going back to 2015, 2016, we saw a super El Nino, and we've had a consistent southeast ridge. Now, around 2015, we flipped the AMO from positive to negative, and it's been pretty steady state negative since 2015. What we have dealt with.
Does that impact the hurricane occurrences?
Yes, it will impact the hurricanes in a couple of different ways. One, if you look here at the AMO, here's our current state on these sea surface temperatures. You can see much warmer than normal waters off the East Coast. But if you look down in the main development region where you typically get tropical activity to develop, it's actually slightly cooler than normal. So what you can get here is it may be harder for storms to actually develop. You may have a lower number of hurricanes, but if you get a hurricane or a tropical storm to develop along the East Coast there, they could be stronger. And you've absolutely seen that the last several years. I mean, look at Hurricane Harvey, Michael, was it Florence, I think last year, all formed near the East Coast or the Gulf of Mexico and ended up being very strong. We may not have a lot of storms, but the ones that we could see could be pretty strong in a threat to the US. That's something to keep in mind. The other thing the AMO affects is our seasonable temperature here, especially for the East Coast. Not only temperatures, but precipitation too. If we look at the drought frequency up in the top left corner there, we're going to get at the load here. You can see that it certainly has, there we go, a big impact on the potential for drought. So just simply put, we are in a negative AMO and a slightly positive PDO state right now, with PDO being the opposite of the AMO just for the Pacific Ocean. And you can see with our red circle, when you get all these blues in here, it's indicative of a much smaller chance of drought activity in the summer months. So that's the setup we have right now. And it's mainly because this strong Bermuda high down here in the Atlantic Ocean. When you have a negative AMO with an El Nino, you get a stronger Bermuda high. You can pump in more heat, more moisture into the eastern United States. And then when you have a positive AMO, your warmer temperatures are up near Greenland, or they're down in the main development region near the equator, and you have a weaker Bermuda high, which makes it more difficult to get that southeast ridge. So when all is said and done, when you have this, it enhances the risk for East Coast warmth, and it certainly enhances the risk for heavier precipitation events in summer, especially for the East Ag Belt and probably the central US.
Yeah, and that's a great point. The last point you made on the Eastern Ag Belt, we're already seeing it really. This ridge, the southeast ridge develop, and this southwest flow coming the next couple of weeks is just going to inundate the Ag Belt with rain. So Nathan, on this drought frequency map, you see we're talking about the AMO, but of course the PDO is another factor. So talk about, Nathan, the PDO. Or actually, let's go to. I'm going to go one slide ahead, and I'm going to come back to this. I thought we had a PDO slide. We have a PMM slide. My apologies. Okay, so long story short, the PDO, as you see in this graphic, it is positive. The PDO is positive, and the PMM is somewhat close to relation in that. But talk about the PMM, Nathan, where it's at, and kind of what our research, is telling us with the PMM. What is the PMM?
Yeah, so the PMM, we're just looking at the surface water temperatures here. Basically from the Baja of California, you take that down through the west coast off Mexico down to the equator. And when we see changes in those temperatures, that changes the structure of the overall jet stream, and that influences precipitation. So precipitation is a big player here when we look at this PMM, and it's very positive right now. We're looking at the current sea surface temperatures here, and notice how warm they are out here in that area. When we see that tongue,
how do we know it's positive, Nathan?
And we know we know it's positive because of the warmer than normal temperatures all throughout that area.
Perfect.
And typically when you have the warmer temperatures, it's going to lead to a more active subtropical jet stream. That's where our subtropical jet stream will come out of here and originate from the Central Pacific. It rides up into the Southwest and Central US. And whenever we see that tongue of warm water there, again, from the Baja of California down through the equator here towards the Central Pacific, that's a good signal and sign that you're going to have a more active subtropical jet stream, and that will enhance precipitation risk for the US. So we look at summers with El Nino with a positive PMM, which is where we are now, and very likely going to continue to be that way through the summer. Those years were very wet. A lot of green on the map here from the Central Plains, the Ohio Valley, and also kind of showing a slightly drier potential for perhaps the upper Midwest. If we were a negative PMM, that would be more of a drier concern for us. But right now, absolutely not looking to be a negative PMM. I do think we're going to continue to see positive PMM for the summer, which just means, again, just a stronger subtropical jet, more moisture getting fed into the US. So again, more research there showing the support for a potentially wet summer here for the Ag Belt.
So to touch on this too, the PMM is often, related to and driven by El Nino and ENSO. So we're seeing this strong positive PMM, which in turn can mean a stronger than normal subtropical jet stream, which is the reason for the positive PMM analogs here on the left. I want you to remember this analog on the left when looking at Illinois, Indiana, Missouri, Arkansas, that central US piece. There's a lot of historical analog research and data that has that area very wet, especially midsummer. So we'll get to that in a second. To sum up the PMM, to try and find, hey, let's say, could we dry out? This is a very good indicator to watch. If we start to see the waters cooling in this region, that may be an indicator that maybe the pattern will dry up. We're certainly not seeing that right now. Okay, so let's go to our summer analogs. All right, we've kind of discussed some of our methodology behind our analogs, the AMO, INSO, the PMM. That's kind of what some of our analogs have been built on. And we've chosen those indicators just from experience to what we feel like what drivers really control the summer pattern. That's just kind of what we've learned here the last couple of years. Now, this analog package here, again, is constructed of everything we just talked about. You can see that anything that has like all green across, those were years that everything, all of our parameters lined up. A couple of them only had 3 of them line up, but most of them, these are pretty good fits. So what we've done is looking at the AMO, the PMM, and the INSO evolution, we've constructed our own analogs. And what you can see here is some of the most recent ones you might remember: 1991, 2004, 2015. Those are some of the most recent years. Okay, again, I want you to understand these analog maps and what they are used for, generalized ideas here. Okay, June, what this tells me is, this doesn't tell me it's going to be a drought. This tells me hit and miss precipitation chances based on this analog package. As we get into July, this tells me it could be very wet with possible flash flooding concerns. 2015 is a prime example in July of flash flooding. We broke our daily rainfall record in July of 2015 in Indianapolis. We had almost 8 inches of rain. Those types of heavy waterlogged storms in these El Nino summers are possible. Okay, August, August can be a somewhat of a drier month, perhaps, in the northern plains. That is some research that we have seen, and it can be wet further south, because if we work in a trough or some cooler conditions and shove that precipitation pattern out of the Corn Belt, that is a possibility. So we'll look at this. Again, these are our analogs. We'll look at temperatures. Guys, our analogs overall are pretty chilly. All right. For the most part, June is pretty chilly. A big trough in there. July can be probably the warmer of the months, but with a gradient like this, from Texas into the Tennessee and Ohio valleys, it could be very, very wet with a thermal gradient like that, and that's why those analogs are wet, no question about it. July, in our opinion, is probably the wettest month of summer, with the most elevated risks for flash flooding and locally heavy rainfall. Okay, and then August. Here's the wild card with August. We talked about INSO. Is it going to stay steady, or is it going to weaken, or is it going to get cooler or warmer? So, kind of what we're all thinking is that we kind of steady as she goes with INSO. I think it's risky to forecast an INSO decline in August when we have nothing that supports it right now, and our historical analogs really don't support it either. Even the evolution analogs, there's really no support for that. So that's the analogs are definitely on the cooler side of things. The data is pretty warm for summer. The analogs are pretty cold. So that's fun, right?
What's interesting too about that August, another year that comes to mind is like August 2017. It wasn't one of the coldest months on record for that August. So if you continue that El Nino and it continues to be a large influence, I mean, there's a lot of support for cooler and maybe even a little bit drier August as well. So
yeah, if I recall in 2017, that the coolness saved a lot of folks in August because it was so cool, but it was dry. We were drier. It kept it going. So here's what these analogs look like as a whole. June, July, August. Again, they're pretty chilly. Okay, 69 is the best analog. It's double weighted in these actually. And everything lined up. The evolution was the closest. 69 is really tough to not use 69. I don't know how you wouldn't use it. And then precipitation, again, here's the general theme. And the only reason I keep reiterating this is because I know how people are, and they're seeing this. Oh, BAM's calling for much below normal precip in northern Iowa. Now there's going to be a drought. No, that's not what we're doing. What we're saying is the general pattern for a large chunk of the U.S. has a lot of green in it. There is some suggestions that the northern plains could be drier. Overall, if you're a half inch, even 2 inches below normal precip for the whole summer growing season, that's still not a big deal.
Yeah, and let's also remember that from like southeastern South Dakota, southwestern Minnesota, northeastern Nebraska, we had about 8 blizzards this winter. And since last growing season, we're the wettest by far on record in that area. So it's going to be really hard to just magically change up that storm pattern.
Yeah, it's great points. So let's get into the next slide here. And I want to talk about this methodology and this approach. First off, we don't forecast yields, all right? So if you want to know what our yield forecast is, we don't have one. But what we do is we look at weather conditions and we look at what the yields were, and we simply present that to you. I will tell you that 9 out of these 22 different years plotted finished slightly below trend line yield. Most of all of our data was at or above trend line yield in almost all of our research. What we did is these green dots, they are our analog years. The only 2 years that were really bad was 91 and 93. Now, 93 is a year because of the current ongoing flooding and the continued wet forecast. There's no way to discount out to say 93 is not relevant. There's still video every day of water rushing over fields and roads in Iowa, okay, in Nebraska. So that there's a very serious problem there. And there's a lot of people I don't think will be able to actually plant crop this year. I really don't. So 93 is a potential outcome. But there are also other very wet years in here as well that were above trend line yield. So right now, it's basically a 60% probability based on analogs that yields would be above trend line. Now, the blue dots are simply looking at solar activity. The low solar from most recent years indicates above trend line yields, okay? What it essentially means is cooler, wetter growing seasons, really, is what it correlates to. There are a couple at or below trend. They're not really, I mean, we're going back to the 70s and the 60s. They're not incredibly relevant. Regardless, you can get an idea of what our, analogs are saying for yields. Take it one way or the other. It's basically where we leave you with that.
Yeah, one point too is on the flip side, our ones last year, it was almost 60-40, maybe it was a little bit more than that were suggesting that at or slightly below trend line yield as well.
It was 8 out of 12.
Yeah, it was quite a bit, which did end up happening. So
yeah, we ended up, below 2017's numbers.
Yeah, and then the year before that, ours were above the trend line as well. Yeah. So this is a good methodology from a weather standpoint, not giving you the yield, but giving you indications of recent years and how that's developed.
Yeah, for sure. So, all right, models that agree with the BAM forecast. Let's talk about this. So we have the European model on the top left. On the bottom left, we have looks like a blend, Brett. Multi-system seasonal forecast.
Yeah, that's the blend of pretty much all of the models that they can come up with. So.
Okay. You see the general theme. This is on top. This is the Canadian. On the bottom right is the DWD, which is a German model. It's definitely the cooler of a lot of these models. But the theme here is there's a lot of indications for central U.S. cooler than normal conditions to be present. Okay, that's the European seasonal, and then the mean of everything. The reason the mean is a little bit warmer is because it's factoring in the Meteo France. That is a blowtorch, and we'll talk about that. But what we're showing you right now is models that agree with the forecast. But guys, let's remember the winter forecast, the winter outlook, the models, none of them were correct. Even the ones we thought would be were not. So these models are tools, but let's not spend a lot of time on them.
If I can add one thing, one of the things that we're looking with these, they don't have to be 1-to-1. We're looking for a general pattern, something that says that's close to our outlook to say, okay, there's some support for it. It doesn't have to be 1-to-1. This DWD is colder in the south central US. We don't think that's going to happen. We actually have it a little bit warmer down there, but it does show the general idea that there's going to be more cool air to work with for summer, and that's the main takeaway from these.
Yeah, absolutely. Great point. So to go to that, now here's models that disagree with our forecast for the most part. That, like I said on the top left, this is that Met Office. Is that Met Office? Is that the UK Met? UK. I'm sorry, I said the Meteo France earlier. Okay, so those two are obviously skewing that average model output, but you can see it's obviously way warmer than our forecast, no question about it. The Jamstack is, the NMME is, which is the multi-model ensemble from the Weather Service, from NOAA. I've never seen this model in a seasonal aggregate, never. I've never once seen it predict colder than normal temperatures. So I don't think the model is capable of even seeing it. A lot of people really think it does a great job. I don't understand that methodology of the MME. I've heard it does good on precipitation. If May pans out the way it's going to be, the MME precip forecast will fall flat on its face. It will not even come close. So the model, you can kind of draw your own conclusions with models, but models that agree on precip, there's a lot of wet models for summer. There's a lot of data that's very wet. There's the MME, there's the DWD, the CFS, the European, everything is the Canadian, everything is really wet for summer. There's really no, and a lot of it looks like our analog packages. So that's either really good or really bad. We haven't decided which one yet.
What's interesting about models too is they are extremely based off of El Nino or ENSO evolution. So if you start to see the models at the end of the summer or into the early fall really get warm and dry, that's probably the model forecasting ENSO to decline.
Yeah.
Just an example. And if you see it linger, that would just be it lingering El Nino. So if it's wrong with its forecast on ENSO, it will be wrong in its seasonal forecast.
Mm-hmm. And yeah, for sure. No, nothing to add to that. I mean, models that disagree. Here is the European seasonal. It's still pretty wet in the growing regions. It's drier to the south, so you could say it's 50-50 with our forecast. The Met Office is, it's kind of neutral. It's not above or below normal precip. So, again, you could kind of say it's a 50-50. Most of the data that we've looked at is wet. I haven't seen a dry suggestion from anything.
If there's anything, just to add to that, at times parts of the southeast have been drier, whether that southeast ridge, because of that negative AMO, can flex that feature. So I think if in my opinion, if there's anywhere, and we've discussed this as well, to have at times some drier risks, it will be as that southeast ridge can flex down there.
I think that southeast ridge will show up a few times in the next few months. I do. I think that's going to be, and that is only going to exacerbate flooding potential and problems. So, Nathan, talk about the drought monitor. Let's talk about where we were in 2018 at this time, what we were thinking versus what we're thinking right now. I mean, it's not even this.
Oh, yeah, it's a whole different world. Last year at this time, we were still dealing with effects of an ongoing drought in Kansas, Oklahoma. And, we thought last summer that would kind of play a role in how things would trend throughout the summer. Typically, when you see drier conditions, sometimes it can lead to more high pressure, more upper level rigidity in the atmosphere. And there's a lot of changes that have occurred since last year. When you look at the drought monitor, little to no concerns, not just around the Ag Belt, but across much of the U.S. The drought has been erased across California, pretty much erased all across the Southern Plains. Very little in the way of drought going on. So this already shows you that we have been in a very wet pattern. And it's been interesting because, we think back to the winter, the pattern really was kind of the opposite of what a typical El Nino would bring. We've seen this very interesting, the ocean's been more El Nino, but the atmosphere many times has been seeing more La Nina characteristics, and we're even seeing those characteristics going on right now. So it's been interesting that we haven't followed suit with a typical El Nino. And when we look at the years that were most similar with the wetness that we have seen and the wetness continuing in the summer, you can see that there's right now no drought concerns. And as we look forward into the summer, certainly not going to see any real problems because of dryness, at least the way things appear now.
And just to add to that too, if you go back to the image real quick, when you think El Nino, you think active subtropical jet stream, and it really does matter where that's oriented. So that's why we pay so much close attention to ENSO, because if we can see El Nino developing, that sets off bells in our heads that, man, we're probably going to see a pretty active subtropical jet stream, and we can erase something like that very quickly.
Yeah, definitely. I mean, you can see that right here. So it's a great point. When the rubber hits the road, Okay, here's the forecast. Here's what we're seeing. Here's the risks. What we're seeing, this is the 2019 summer forecast for temperatures. And essentially what we have here is below normal temperatures favored in the central US and basically the primary growing regions of the United States. The corn belt, if you will, the soybean belt, where we're growing most of our crop. The coastal regions, where a lot of it matters for energy demand and cooling degree days, we think that can overall end up above normal temperature-wise, even up into the PNW, the Pacific Northwest. So it's going to be an interesting year, an interesting summer, because it could drive both, the CDDs to be above average, and it could also drive the crop to be healthy and be good. It's interesting to see how this could pan out. But what you see here is that El Nino conditions are favored. The AMO is at near record negative levels for March. Again, that favors or enhances the potential for southeast ridging, eastern U.S. warmth, very wet pattern centrally. High latitude blocking is more likely in El Nino summers, a negative AO. It's in basically every El Nino analog that exists. Overall, El Nino evolution is rare and has not occurred since 1950. Brett, touch on that, because you wrote that.
Yeah.
So what?
It hasn't occurred often since
What hasn't
1950. This evolution of Enzo that being so steady
Okay.
through all of winter, all of spring, and all of summer. 1969, even it fluctuated a little bit, but this evolution of being so steady with El Nino is just not normal since 1950. We looked before 1950, and there were quite a bit more years in the 1940s and 30s and even back to the 1800s that did this, but not in recent memory.
So some of the 2-year El Nino events follow some La Nina events that turn pretty dry that we looked at. So that might be something
that is something we'll have to watch for next year's forecast.
2020, let's keep in mind, that's a possibility. So we'll get into the energy side of things in just a second. I have a slide dedicated to that, but here's temperature or precipitation. Again, if there's any drier spots, it's the northern plains eventually. They're not dry right now. We all know that. They have gotten drier, parts of the Dakotas and the prairies, but eventually I think there can be drier there. Again, I think July, which is the month that really matters, is pretty wet. I think a lot of people can get timely rain in July. A lot of people could get too much rain in July. That could be problematic, so that's something to keep in mind. The continued negative AMO, like we said, will persist or aid the resilient southeastern ridging. And like we said earlier, the August has the potential to trend drier. The exact orientation and all that where is still up for grabs. We're getting out there, okay? These precipitation forecasts are very, very, very difficult. We're trying to give you a generalized idea. And for the summer rainfall outlook, the reason we've gone much above normal here is from a historical analog standpoint and just all of our computer models blended together. Okay, there's the tendency or the potential for there to be moisture loaded, thunderstorms that can produce flash flooding in years like 2019. So just something to keep in mind going forward. Okay. When rubber hits the road on the, isn't that neat? Let's just do that again because I think that's neat. Oh, look at that. Oh, let's do it one more time. So there's the population weighted cooling degree day data. A lot of research and work went into compiling this information. And you can see here the European seasonal data is actually hotter in cooling degree day forecasts than it was in last year. Last year we were around 1,000 CDDs, and the Euro is trying to go 1,057, and it's kind of the polar opposite forecast from our July and August thoughts. So we're kind of going against the grain a little bit on that. The orientation of the temperatures are close, but the extremities are just higher. So, but I will tell you that the correlation amongst the ensembles, the 51 ensemble member spread in July and August, is all over the place. There is not a really strong mean signal for these CDD forecasts. There's a lot of noise in the model. So that makes sense. When we look at our analogs, you know, we would finish at an 812, which is, you know, way cooler than the models. And when we look at our rubber meeting the road, all right, we are we an 880? Is that? Yep, we're at 880 for the year for June, July, and August on population weighted cooling degree days. So we think that, you know, 230, 345, 305. And then, you know, looking at the 10 and 30-year normals, we think we're warmer than the 30-year normal, but cooler than the 10-year normal. And I don't think we're looking at a top 10 or even top 15 hottest summer. I don't see that. Is there anything that might suggest that?
Other than the European seasonal, maybe if there are some outlooks out there or companies that are forecasting that, maybe they're just basing it off of the European monthly. With that being said, I was going to bring this up. The European monthly this entire winter was cold, 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 and it wasn't cold. In fact, the CFS model actually crushed it in a lot of the months this winter. I personally have given the CFS model a hard time in years past because it hasn't been very good. But I'd say over the past 6 months, there's a lot of times where I'd favor that model just because it is progressing, you know, with that more of that El Nino ocean state, La Nina like background state here, and has done much better with that. I do find it interesting that it is very close to our forecast, and because it continues to perform very well every month.
Yep. Perfect. So this last slide here, these are some of our most recent analogs since 2000. Brett, talk about some of the research you've come across here. This is basically, you know, giving us an idea on severe weather and what it may bring this summer.
Yeah, so some of these maps may be a little hard to read. It's just the accumulation of all of the severe weather reports for each summer. So the years here are 2005, 2003, 2004, and 2015. Now, 2005 and 2003 weren't on our final analog list, but they were ENSO evolution analogs. And since 2000, they're decent enough that we can use them here. And we've got a general theme. The central US here has above normal hail and perhaps wind risk. And of course, flooding too. On the right, what Michael just circled is actually the flash flood guidance. And that's something that we need to consider too. So if you've got events or even just a field that you need to be monitored, this is something that we can look at and say, hey, flash flood guidance says that if you get 3 inches of rain in the next 3 hours, you're going to see a flash flood warning or flash flooding issue. So that's obviously a big concern too, given, as Michael has touched on at length, the amount of moisture that we're expecting in the atmosphere, in the soils this summer. And one more point on the severe weather here. You can take a look, even 2015, it's generally a look at climatology. Generally, it looks like climatology, but some of these years are much more robust and just goes to show how big of a deal severe weather, even in the summer, even in kind of the off season, it can mean. Hail damage averaged in these years $155 million, wind $150 million. I think that in the plains this year, that could be an issue.
Yeah, I mean, you look at, was it 04? We've got 04 here on the top bottom left, where you had hail damage at $348 million. So, you know, some of these storms may have tendencies this year to produce more hail than normal. You know, just the moisture's there, and the clash, the thermal gradients are there because, as Nathan stated, the atmosphere has resembled more La Nina-like characteristics, and hail and La Nina really like each other. So whether or not we're in an El Nino, a lot of La Nina years typically are pretty severe weather loaded and hail. I know around here I've done studies that we see more hailstorms in Indiana based on La Nina severe weather seasons. So
yeah, I got a clarification too. Maybe that might confuse folks when we say the atmosphere is La Nina, the ocean is El Nino. Maybe you want to touch on what that means.
So essentially, guys, when we say that is the atmosphere and the ocean are decoupled, and they're not on the same wavelength. And so what happens is it not only is it make the weather pattern chaotic, it makes it hard to forecast, but the atmosphere can behave as if we are in a La Nina, but we're not in one. It's the easiest way I can put it. You know, if we're not seeing the the character, even with our angular momentum, we have a very high angular momentum, but at certain spots in the northern hemisphere, we've got suggestions that angular momentum is behaving more like La Nina, a retracted jet and different things like that. So it's very complex, but very simply put, you can behave like one and be in another, vice versa. And that's what makes having a weather service, someone who monitors this stuff daily, so important, because you would never know that would be possible. So I want to open up the floor for questions. I do want you to know that if you are not a subscriber, you've been considering subscribing, we have a heck of a discount today only. Okay, you have to sign up today. You can't sign up in 2 days or next week. We'll offer you this discount. Would love to have your business, but this is an example of the analysis that we put out every day. This is what we're doing every day for our clients. We're not 100% accurate every time. We don't get it right every time, all right? But about 8 out of 10 times we get it right. We're gonna miss one, we're gonna miss two, and we're gonna tell you why. You're gonna know when it happens and how it happened, and we correct it, and there's accountability there. But with our service, it's what you see is what you get. We're not out trying to lean one way or another because of a certain situation. What we're doing is giving you what we got. So what I want to do is open up the floor for questions. If you have any question or any interest in signing up, please do contact us. And I'll leave the floor open. Let's see if we have any popping up. Brian said any questions, enter them into the window or the chat. So do you guys have any last closing remarks that you would like to make before we get going?
I just say I appreciate everybody coming on. I get often asked, what's the difference between what you do and a free weather app? Well, we really love what we do every single day. We're not robots. We're not computers. We tell you the biases in the models, why we disagree. That's knowledge and experience, and just doing this every day, for 10, 12 hours every day. You can't get passion from a weather app. You're making a business decision, whether it be farming or whether you're an event forecasting and you're responsible for 100,000 people, or a concrete pouring job. You don't want to rely on a free weather app, because who's responsible for that if you get that wrong? You want somebody that's professional, and we would love to earn your business with that, because we're very passionate, and if we weren't right, nobody would pay us to be right. So I just want to say thank you for everybody coming on, and we really, really do appreciate it, because it wasn't for you guys out there, we wouldn't have a job.
Yeah, absolutely. Great stuff. So Mika says, you guys mentioned the heavy rain events in July 2015. Worth noting, those were very localized. For instance, July 2015, northern half of Anderson got 4.5 inches of rain in 90 minutes. Almost none of the county got a drop, and a 3-block cutoff. Very common in these summer patterns. These hit and miss storms across the street can be big, here can be not. No way to predict it. No way to know. But I would suspect there's going to be plenty of that going on here this year, no question. So great statement there, Mika. And then Miriam, your prediction is just through August. Yep. Excellent presentation from James. Thank you very much. I appreciate that. Thanks for checking it out. Willie says, will the wetter weather, will this bring more tornadoes? Not necessarily. No, I don't think so. I could even venture to say tornado activity would be below normal. I think tornadoes would be a little bit more quiet this season than normal. So we've already seen that, really, except for the exception of the deep south. But for the most part, no, I wouldn't. So great questions. Any other questions we can answer for you before we sign off? We're thinking about lunch. We're hungry for sure. I'm sure you all are as well. So Mark asks, how about a fall autumn outlook for the northern plains? We don't have one right now. It'll be soon. We don't go that far out, for the simple fact that going out to summer is already hard enough. So I appreciate the question, Mark. I just don't have an answer for you right now. So we'll keep an eye on it, and we'll let you know in the coming weeks.
Just another reason to subscribe.
Yeah, another reason to subscribe, get our information. Excellent weather. Weather is fascinating. Always been a farm person, so I watch the weather. Thanks for the predictions. No problem. Thank you. Thanks for watching. Appreciate that. So any other questions, guys? There's still a lot of you in here. Does anyone have any other questions they'd like answered? I'll kind of scroll back to the outlook so you can just kind of get an idea. There's our precipitation and there's our temperature. So I'm going to give it about 60 more seconds and then we'll call it good.
I got one maybe we didn't touch on. How do we feel about 90-degree days? Above normal, below normal?
I think 90-degree days are below normal. I would even venture to say we could struggle to have them in Indianapolis. I would venture to say that
August is one of our bigger 90-degree day months of the year. I mean, if you're flirting with an August 2017, you're right off the bat, you're talking a lot less.
We researched some years, or analog years for different cities across the Midwest, and pretty much all those cities average just slightly below normal, what would be typically normal for 90-degree days. So we do think it'll be a little bit less this year.
Yep. All right. So we said, do you think Indiana sees many 90 to 100-degree days? We just answered that. Thank you, Brandy. Is May going to dry up any in Indiana? So research says that the second week of May and beyond can turn drier. Persistence in the pattern says that will be hard to do. That's the best I have. I mean, there is support for a drier second half of May. Yes, there is. Will it happen? That's kind of a week by week prognosis right now. So,
keep an eye on the Southeast Ridge.
Yes, that's the key. Thank you. This is my first BAM webinar and it's been very useful. Look forward to more. Thank you very much. Below 90 degrees would be wonderful. Yes, it would be. So, all right, guys, thank you all so much for tuning in. Please get at us if you have any interest in signing up with us. Would love to help you out. We wish you all the best of luck this year, and we'll talk to you again soon.